Hello everyone, today we have a special little video. I'm going to play basically and comment the Stgw 57 manufacturing video. I gotta say, even after having edited all these hours of footage and selected these individual clips for your enjoyment, it never gets old. Now the purpose of today's video is to really kind of break down essentially every pixel behind this video to allow you to better understand the sheer amount of work that goes behind manufacturing hundreds of thousands of accurate, precise, reliable rifles. So let's get right to it.
La fabrication de plusieurs centaines de milliers de fusils d'assaut.
Now here you can see basically, and it's very well outlined here, the individual processes necessary to form the center sheet metal section for what is called internally at SIG the receiver front section, Gehäuse Vorderteil. You can see it starts out with a kind of a T-shaped blank. I think this is mild steel, if I'm not mistaken. It has been specially annealed for these relatively intensive forming operations. And you can see basically in one go, the edges are folded up, and you can see the ejector cam and the opposite shelf are formed. The rear sight base, I would say plug weld hole, if that's the right term, is coined out or blanked out. And then subsequently you can see the skirts are folded inwards, the reinforcing ribs are embossed, and then the seam that is now formed is machine welded over. And you can see here it has been neatly ground, and kind of the reduction right here for the receiver front section trunnion is also removed. Now on the bottom here has excellent view on the individual components that go into a receiver front section. You have of course the receiver trunnion, Gehäusekopf, I think it's called internally on the drawing. Here is the charging handle rail, Riegelführerschiene or Schiene. I need to touch up on my German. Basically a profile steel section that has some cutouts. The rear sight base, this triangular profile steel section you see here. The receiver front section rear trunnion. The reinforcing bracket as well as the U bracket and the tube for the trigger housing. So all of these are kind of tacked onto the receiver front section kind of middle stamping, you can see here, and consolidated with spot welding and hard copper brazing. And once all of this is done and the subsequent finishing operations executed, and these involves the stamping out of the charging handle port, the ejection port, etc., etc., you can see that here the receiver is finally sandblasted and blued, ready for assembly. Now what comes next is the folding of the T-shaped blank, you can see right here. So this is a relatively heavy tonnage press. You can see the operator pressing both buttons as kind of the fail-safe. And then you have, of course, the ram of the press that comes down, and here you have the die, and that basically squeezes, you can see right here, the edges flipping up. It squeezes the workpiece, in this case, into the relevant shape. And what comes next is that the operator extracts the workpiece, and inspects it, and can clearly see here the ejector camming surface being formed. So pretty cool stuff. Really shows how sophisticated stamping is as an operation. Now what is interesting here is that this is not a Stgw 57 semi-finished receiver, but in fact one from the SG 510-4. It was co-development with Beretta in the early 60s as kind of an export-only product to compete against existing battle rifles like the FAL or SETME series of roller delay blowback rifles. These were purchased by the Chilean and the Bolivian army, and you can see here it's written Ejército de Chile, basically stating that this is Chilean government property. So this kind of shows you relatively from the get-go that this is not a Swiss Army rifle. What's happening here is the center stamping is being joined with the machine, the drop forging and the machined front trunnion. You can see the relatively specialized spot welding setup with the two copper electrodes. The operator lines them up, brings the electrode down, and then a current is applied, thus forming a nugget of molten metal that basically bonds both parts in place. So pretty cool things. Now subsequently, of course, the receiver little pieces aren't actually just held on together with spot welds. As I mentioned before, there's an extra hard copper brazing step, and that really consolidates all the parts in one. Now what follows after
Zivilen Pressluftapparate teilen parallel
is kind of a mysterious process. I'm not really sure what's happening here. It looks like some sort of bucking bar or die. I'm not really sure. Maybe he's doing some sort of quality control to kind of analyze the relationship between these parts, I would say. But what's interesting is if you take a look at what he grabs afterwards, he takes a hammer and some sort of unidentified shiny object. It kind of looks like a stamp. So I would say that this is kind of an inspection step. If you notice that on the receiver, there's a marking strip, and sometimes there are cryptic symbols that are stamped on there. I would say that these are probably to denote critical quality control steps and to show that the receiver basically passed this inspection. So that's relatively interesting. So here what's happening, and you can see the receiver being fitted, is the spot welding of the reinforcing bracket. Now the reinforcing bracket is a profile steel section. I think later variants are fine blanked out of heavy gauge sheet steel, and you can see that the receiver is being kind of shoved onto between basically two copper electrodes. Now what is happening here is that the upper electrode comes down and a pretty strong electric current is applied. And because of the natural electrical resistance in the steel, this eventually causes this area you can see right here to heat up pretty drastically. And this kind of forms kind of a spot weld nugget. There's essentially a solid core of molten material, and that basically fuses the reinforcing bracket with the stamping together. So it's pretty brilliant stuff. Now you can see here there's this piece of steel with some cryptic markings. I think this is kind of a fixture to index the reinforcing bracket in place prior to spot welding. You can see here that it's very clearly marked. I think this is something AM55 Gehäuse Vorderteil or receiver front section. I guess this 328 something number is going to be the actual number of the fixture. Slash some cryptic number I can't read, and operation something. So this is, you can see that it's very clearly labeled to make sure there's no mix up with any other jigs and fixtures necessary for production.
lässt sich nicht beweisen. Reduktionen der Kapazität.
Now this is an interesting sequence. So you can see the operator here is clamping a receiver front section in a press, and you can see here, if we go frame by frame, the receiver front section oriented basically muzzle forward, so to speak. Now pay attention very closely to this kind of square section. I believe that's the blanking die, and this removes a section of material that is supposed to represent the ejection port. If I'm not mistaken, the ejection port on the Stgw 57 is formed in several operations. The first one is pre-coining. There's a basic profile that is being removed by this press. Now you can see that he places both hands down, presses probably what is a foot pedal. There's a guard that comes straight down, and then you can see the press that bears down on the part, and the die essentially punches out the material, and you can see, I don't know here, there's some missing material, and he basically flips all the clamps out of the way, removes the workpiece from the machine tool, and basically removes what is the internal piece of tooling right here. You can see this part, and he carefully inspects it, places the workpiece, looks at the piece of tooling to make sure that everything is in line, and then repeats in subsequent operations. Now you can see here in this case the ejection port as well as the charging handle slot have all already been formed. What is happening here is a very critical machining step. It's basically the boring and counter boring of the receiver mortice recesses. You can see it's made on a very sophisticated machine tool. I think it's called a kind of a Posalux machining center. the table, which is this rotary thingamajig right here, has all of these individual fixturing plates or fixture plates, fixture elements, whatever you might call them, for the individual semi-finished receivers. You can see all around you have these individual spindles, and each will execute a particular operation. So I suppose there is the first operation would be boring the actual hole, and then it would be chamfering, counter boring, and then finish reaming, if I'm not mistaken. Now what's interesting about this Posalux table is that, if I'm not mistaken, what can happen is that the operator can flip the pieces when the table is indexed several positions. So this allows machining of both sides of the semi-finished receiver. Now you can see here the operator basically removes a finished part from the Posalux machining center, clears the chips with an air blast, and here's the part that I'm not really sure what he's doing. I mean, looking at the tool that he's about to grab, there's kind of a round area, so I assume it's kind of a dial gauging, but to be honest, looking back at the way he manipulates it, I would probably say that this is kind of a deburring operation, so to remove any excess material that has been pushed away by the cutter. You can see that he fits it into the trunnion holes, and then he very cleverly or smartly spins it around like this, and I guess this tool kind of deburrs and slightly chamfers both sides of the trunnion in one go, so pretty cool. So he kind of spins it around, gives it a deburr. I suppose this is what's happening.
Seront remis à la troupe en 80.
And then here you can see that he grabs a cylindrical go and no-go gauge, tries the go gauge first. You can see it here, flips it around. You can see the two ends of the plug gauge, and then inserts the no-go side to confirm that the hole is indeed within specification. Now notice right here, if you look at the rear sight base, there aren't the holes for the diopter. I think this is a subsequent operation where both sides of the sight base are milled. So this is to have a consistent thickness, and then subsequently the holes for the diopter interface are then bored out. So this is still a semi-finished receiver right here.
Stgw Tieflochbohrmaschine. Damit werden alle Arten von tiefen Löchern gebohrt, zum Beispiel Gewehrläufe.
You can see right here, this is probably one of the most critical steps in barrel making, and this is deep hole drilling. The basic problem is very simple. You want to have a hole that is as straight and centered as possible inside a long steel blank. Now in the case of the Stgw 57's barrel, what is usually used is a high purity chrome nickel alloy, in this case ECN35. Now you can see right here you have an automatic feeding device, and on the top left you can see the four boring bars, so to speak. Basically there are the pieces of tooling that will actually remove the material to create the long and straight hole within the blank. Now what's interesting, you can see right here, the center part of the blank still has the original kind of raw finish, but the ends have been carefully machined and chamfered. So this is to kind of prepare the blank for the machine. I guess there's some sort of semi-automatic or automatic clamping interface, and that's what starts kind of the deep drilling operation.
Die Stgw will 2 solche Maschinen nach Chile verkaufen. Lizenz und Pläne zum Eigenbau des Sturmgewehrs hat sie schon verkauft. Gesetzlich ist der Handel sauber und löste dennoch einigen Wirbel aus. Doch in einer...
I don't know if you noticed, but there is basically kind of a clamping apparatus that's just pushed forward, and that basically just pinches the workpiece in place, and you can see the spindles right here move around at a fast rate. The boring bar, for lack of a better term, if anybody has the actual technical term for this, is then pushed forward, the drill bit, you can say it that way, to actually remove the material.
Öffentlichen Erklärung stellte sich auch der Betriebskommissionspräsident hinter das Vorgehen der Firmenleitung. Auch die Erhaltung von Arbeitsplätzen sei ein humanitäres Argument, sagte er.
So once the hole is drilled, the external part of the blank, what's remaining, the rough surface, is basically turned off. Now this is extremely important. The internal surface finish of the bore, as well as the quality and tolerance of the outer diameter of the blank, are of extreme importance, especially for the subsequent hammer forging operations. So as I mentioned before, the internal surface finish of the bore is important. So in this case, this is kind of a super finishing operation for the internal bore. The idea behind this is that you would remove a lot of the tooling marks that are left by the previous deep drilling, and you would run basically a polishing bit back and forth to remove a lot of the tool marks.
Sa nécessité militaire fut définie.
Now this right here is the star of the show at SIG. This is, I think, a GFM brand cold hammer forging machine. So the principle is really quite simple. The blank, which has had the whole super finish, the external profile turned, is basically fed into this gigantic machine right here. So on the left side, this is kind of the holding chuck that can slide back and forth and can rotate. And on this side are two pairs of hammers that can basically oscillate back and forth. And in the center, you can see right here, is basically a pilot to align the blank in place. Now, what you don't see here that is extremely important happens on the inside of the chuck. Now, on the inside, there's a long rod, and on the very tip is a tungsten carbide forging mandrel. Now, basically, it contains essentially the negative shape of the rifling that you want to form.
Arbeit an der letzten Lieferung fürs alte Sturmgewehr.
À la suite de quoi, on procéda à l'analyse des aspects financiers, des délais de mise au point et des conséquences sur le plan de l'instruction.
So you can see basically what's happening here is that the hammers are basically squeezing the material, and inside of the hole, what's going to happen is the material is going to flow around the tungsten carbide mandrel, and as the blank is fed forward, this results in the correct negative pattern, or in that case positive pattern, of the rifling. Now, there are a lot of things that could go right and wrong with this process. What can happen if the hammers are not well adjusted, or if the material is not fully optimized for the process? You can have over or under forging, in the sense that the material folds over itself too much. You can also have phenomenons where the mandrel can be too far forward or backwards, resulting in deformed rifling. So it's a very, let's say, it's a setup that takes a long time to set up. So you can understand that once you have the formula, you basically do not deviate. So any change in the geometry of the tooling as well as the material will have significant impacts on the final quality of the result.
À cette analyse succéda la définition des exigences militaires posées à cette arme nouvelle.
Une machine spéciale usine les rayures du canon. On a placé dans le canon un mandrin au profil en saillie. La machine travaille avec une force de 140 tonnes à une fréquence de 1000 coups par minute.
So the narrator here mentioned that the peak force, the peak striking force of the hammer is 140 tons at a frequency of about 1,000 blows per minute. So it's really quite a serious piece of equipment. I can imagine how loud it can get. That's probably why the operators are wearing ear protection in this particular clip.
Martelage, le canon se durcit.
So here you can clearly see how much the blank has stretched out. It basically has been spaghettified by the cold hammer forging machine. You can kind of see a spiral pattern. That's basically where the material has been worked, and it kind of tapers off to where the original blank was held. So there's kind of a reduction in or taper basically in the hammer faces, and that basically what defines how much the material is being worked and at what rate.
De nombreuses autres opérations d'usinage suivent.
So here you can see after the bore is basically clean, I guess, of any stray oil or chips, you can see that there is a go, no-go gauge that is inserted to check if the rifling is indeed, or at least the land diameter, if it is indeed in specification.
On dressa alors le détail des conditions techniques qu'elle devait réunir. En 1955, 3 entreprises livrèrent leurs prototypes.
So you can see very meticulous inspection of the rifling. As far as I understood it, 100% of the coal hammer forged blanks are inspected. As I mentioned before, a lot of things can happen. What I forgot to mention is even foreign bodies like hairs or fibers or anything that could affect the hammer forging process can cause significant defects in rifling. So you can imagine if you have a piece of cloth or a fiber that gets lodged in the bore prior to hammer forging, it's basically being squeezed into the metal, and this is basically an impurity, a foreign body that can cause significant problems in the final result.
La fabrication débuta. À la suite d'une précise évaluation.
So once the blank is formed, you can see that the external profile of the barrel is turned in this, I would say it's probably a numerically controlled or an analog controlled lathe.
Le choix du modèle fut fait. Ils furent soumis à de sévères épreuves.
You can see it's specifically quite interesting here is that the thread profile has been formed, but the barrel has not been threaded yet, because I believe that on the Stgw 57's barrel, the threads are actually rolled, not cut. So this is kind of the preparation prior to this process.
Tous les mois, 5000 à 6000 fusils d'assaut quittèrent les ateliers de
So super specialized quality control setup. You can see you got a couple of dial gauges up and down, or dial indicators in this case. And this gives you kind of a static measurement in terms of absolute, or more or less a comparative measurement in this case, and also an indication of run out, if any.
montage.
So you can see just right on top of this quality control setup, you got the operation sheet or the op sheet describing exactly what is being inspected. On top, operation 23 out of I think 50 or 60 operations or so on the barrel. Lauf for barrel, the drawing number for this particular barrel and for what device, in this case the AM55, which is the internal SIG name for the Stgw 57. On the drawing below, you have the dimensions to be inspected. You can see that they're all 0 and then minus tolerances right here. And here it basically says Einstellstück, which is basically the setting gauge, the master, so to speak, corresponds to the max dimensions as stated on this drawing right here. And you would set the dial indicators in such a way that the 0 point represents basically the upper range of the tolerance. So this is pretty interesting. And you can see on the bottom, this is the exact drawing number of the quality control set that you saw below, and the date, which is 10/4/1969, signed off Philip. So this gives you kind of a who is responsible for this drawing and what version it is exactly. So this allows pretty good traceability of what is happening.
À fin 1956, le fusil d'assaut proposé par la SIG fut choisi.
600 Liter Kühlöl befinden sich in einzelnen Maschinen, die zeitweise mit einem Druck von 60 Atmosphären in die zu bearbeitenden Läufe gepresst werden.
Il y eut ensuite le message du Conseil fédéral au Parlement, la sollicitation et le vote des crédits.
So here a pretty critical operation happens. The rifle grenade spigot as well as the bearing ring for the barrel jacket are precision ground. So this is to achieve a good roundness, good surface finish, for a relatively, tight tolerance area. So I guess that's pretty critical. So here you can see they use a snap gauge. So you would have the minimum and the maximum dimension precision ground within this gauge. And this gives you a good indication if these particular sections are within specification.
Commande fut passée.
Das Bohren des Patronenlagers erfolgt an raffiniert ausgerüsteten Revolverdrehbänken. Auch hier spielt der Hundertstels Millimeter eine große Rolle. Denn vom genauen Sitz der Patrone im Lager hängt namentlich bei einer automatischen Waffe sehr viel ab. Wie bei allen Arbeitsvorgängen werden auch hier die Worte Qualität und Präzision groß geschrieben.
So here you can see the relatively old school and incredible setup that they use to chamber the end of the barrels. Here they use a turret lathe. Now what's interesting about this footage, this black and white footage, it comes from one of the subcontractors for Stgw 57 barrel manufacturer, which is in this case Hemmerli AG. Now, if I'm not mistaken, what they actually delivered were not complete finished barrels, but in fact semi-finished barrels. So the barrels are basically delivered without the chamber flutes and without the muzzle brake holes. So basically kind of a semi-finished barrel you can see right here. And from what I understand, the Hemmerli barrels are also conventionally rifled, not cold hammer forged. So you have different specs of barrels, or actually different types of barrels that are made to the same specification and have relatively similar performances. So that's pretty interesting.
Le dernier chapitre de l'histoire du fusil d'assaut suisse fut la livraison à l'armée.
4- bis 6-mal müssen die Läufe wieder genau gerichtet werden. Ein Arbeitsvorgang, der vor der Hand noch vom geübten Auge und der geschickten Hand des Arbeiters besser bewältigt werden kann als mit einer Maschine.
So here you can see the very tedious job, and I think a lot of people lost their eyesight because of this. But jokes aside, the idea was to straighten the barrel because apparently, according to the narrator, straightening by machine is not nearly as accurate and fast as straightening by hand and eye. And I suppose that it took quite a lot of practice to get right. The idea was to observe the light as it's shown through the bore. And you can clearly see if the bore is crooked that the light kind of bends in that way. So by using this pretty specific arbor press, you can kind of squeeze the barrel back into alignment here. Now here that's especially interesting. You can see this dude, he's inspecting the finished rifling, and you can see that the semi-finished barrel is basically as delivered. So with all the features except the chamber flutes and the ports for the muzzle brake. So you have the bell-shaped kind of expansion cone right here. If you pay attention, you can see that he's holding a Carabiner 31 pattern bore magnifying glass. So it's kind of a carryover from the old era right here. It's pretty cool to see.
Elle avait d'ores et déjà commencé par une petite série avant même la commande formelle.
So here you can see why Hemmerli AG wasn't actually involved with drilling all of the ports for the muzzle brake. Is because it requires a very specialized setup. Here you can see the kind of the coolant line where the cutting oil is sprayed, and the various spindles right here that drill and chamfer the holes. So pretty cool to see, really.
À partir de 1959, on put parler de fabrication à l'échelon industriel. Ce développement commença en 1952.
Now, right here, what we're seeing is kind of a final heat treatment for finished barrels. Basically, there are two types or variants of barrels. Some were kind of case hardened and requenched in the breech portion, or the breech end, which you see right here, and others are soft nitrided or tenifered after 1970. So in the case of case hardened barrels that you see here, you can clearly see that they heated the rear part of the barrel and then it is requenched, so that means that the breech end of the barrel is significantly harder than the front end. Most likely this was done to reinforce kind of the chamber area, especially the contact face of the barrel that is directly being struck by the bolt face. So understandably, these parts of the barrel need to be extra hard.
Enfin, en 1961, l'élite commença à être dotée de cette nouvelle arme.
And you can see once the rear part is heated, it is then quenched, and that basically hardens the rear part of the barrel.
Plus tard, le fusil d'assaut est devenu l'arme personnelle de chaque soldat de l'armée suisse.
Cette machine automatique contrôle simultanément 18 mesures.
So here it's really quite amazing what's happening. Basically, they're air gauging barrels. So a set quantity of air pressure is injected through the barrel, and depending on the exiting pressure, you could easily tell which diameter the barrel is along the length of the bore. So this allows very quick and accurate inspection of various features inside of each individual barrel.
Et les enregistre par un scripteur.
So you can see here the operator here, or the machinist, in that case the quality control officer, has really a whole panel of gauges to inspect the chamber depth, chamber diameter, chamber symmetry, etc., etc. So lots of individual features to control here.
SIG Neuhausen. Hier wird gegenwärtig für die Schweizer Armee gearbeitet, und zwar werden Sturmgewehre produziert. Der gewaltige Auftrag von mehr als einer halben Million Gewehren beschäftigt.
So here what's happening is that they're machining the rear receiver section trunnion, so the part that goes in front of the stock tube that directly interfaces with the receiver front section. Basically what this operator is machining, she's using, I believe that this is a 30-degree chamfer bit. She's milling a chamfer right here, basically to allow the bolts to not strike any 90-degree corners.
Die Firma schon seit langem. Allerdings läuft die Produktion nur noch bis 1974.
Now this is some incredible footage from one extremely important subcontractor for the Stgw 57. Now as a reminder, a significant portion of the individual parts of the rifle are actually not manufactured by SIG, but in fact by small, medium, and large businesses all over Switzerland. Now one of the major subcontractors for, in this case, the receiver, rear section, and the stock tube is Fritz Leibundgut AG. They were based in Grünen-Sumiswald, canton of Bern, and they were responsible for other stamp parts, like for example the rear receiver section casing right here, the flange, as well as the tube itself, and of course the finished receiver rear section. Now you can see, if you pay attention here on the stock tubes here, they have kind of this yellowish, bluish hue. I believe this footage was taken in 1983, and this is definitely a feature on the later stock tubes. Basically what they did here is that they tempered the rear area of the stock tube, because it turns out that because of the flaring or the reduction that is needed for the rear part of the stock tube, this results in excessive work hardening in this particular area. I think a former armor colleague told me that he has observed a defect where this part basically just cracked and the entire recoil spring assembly squirted out through the stock and into the shoulder of the shooter. So not very convenient. So I guess one of the fixes for that is to kind of temper this area to make it less brittle, and then it undergoes further heat treatment. You can see the operator here is placing on a conveyor oven the semi-finished stock tubes. I'm not sure exactly for which process here. Maybe this is for either brazing or it's some sort of tempering or heat treatment. I frankly do not know, but you can definitely tell that this is kind of an oven setup, and the conveyor moves forward at a very slow pace.
Seit 1957 fertigt Leib und Gut Teile für das alte Sturmgewehr. SIG-Raum heißt diese Halle bei der Firma Leib und Gut.
You can clearly see here just how many toolings, fixtures, and jigs are necessary just for one sub-assembly of the Stgw 57. You can see laying on the table here different type of fixtures, etc., just for this individual part. It's really quite impressive how much work goes into this.
Hier wird noch produziert fürs alte Sturmgewehr.
So you can see this operator here is using an impact riveter to rivet either the stock catch or the bolt buffer assembly. So as a reminder, these use rivet pins, and you can either install them by hand, or in the case of the subcontractor from the factory, they use a relatively specialized fixture here with an impact riveting assembly. Now this is the firing pin lever. It's basically what transfers the force of the hammer to the firing pin. From what I understand, these are stamped out of sheet steel. And you can see that this operator here is removing, I think, the burrs and the rough edges from this stamping. And you can see this operator removing the burrs or the rough surface from both sides on emery paper. So lots of manual labor involved.
In den besten Zeiten beanspruchten die Waffenteile 15% von Umsatz und Personal. So viel wird es nie mehr geben. Neues Gewehr hin oder her.
Now this right here is basically another quality control setup, so it's probably controlling the thicknesses of the roller bearing pieces as well as the depth of the hole. You can see a couple of dial gauges when the camera pans up, and essentially 100% of these had to be inspected for critical dimensions. I'm not sure what she's holding in her hand, if these are rejects or just the parts that she is preparing to be fed into this quality control setup. The bipod detent springs are basically what define the bipod in the forward and the rear position. They're basically C-shaped springs that are riveted in place using these things called Chobert blind rivets. I believe that there are two ways to install these. One way is to use a hand tool using a rod that pulls through and that basically swells the other end of the rivet. In this case, I think it's more of an automatic or semi-automatic or more mechanized in that sense method of riveting. So you would have an impact press on top, and that basically deforms the rivet head to keep these in place.
En sous-traitance d'une entreprise privée, on procède ici au montage des fusils d'assaut,
Now the footage I'm showing here is not necessarily what is done either at Waffenfabrik Bern or SIG for assembly of new rifles. What is being shown here is, I believe, a very specialized barrel torquing setup for refurbished Stgw 57s. If you go to lower level cantonal arsenals, these are usually tightened using hand tools, surprisingly, and there actually wasn't really a torque value, so to speak. There were lots of rules of thumbs on how hard you could torque these barrels. Some say 1/7 of a turn after the friction point, etc., etc. But the issue with that is, depending on the physical strength of the person tightening the barrel, you can either get very bad or very good results. So definitely not very consistent. But in this case, using this kind of setup, I guess it's pretty much foolproof.
On prévoit un manque d'armes au cours des années 90. À cela s'ajoute encore le nombre toujours plus grand de fusils d'assaut qui doivent être liquidés, faute de pouvoir être révisés en raison de leur mauvais état technique.
So here you can see this is a Waffenfabrik Bern employee reassembling a refurbished, or in that case overhauled, Stgw 57. So on an industrial level, Waffenfabrik Bern was responsible for overhauling the worst quality of rifles. They call these quality class 4. They're basically rifles that are seriously defective, heavily corroded, or have deformed parts. And the idea was to make them like new again, with complete teardown, refinishing, new parts, etc., etc. Now in this case, you can easily tell that this one has been overhauled. The furniture, the stock, and the handguard are of a matte color. And of course, some parts have been renumbered, so the original serial number have been ground away. And in this particular case, I would say that this rifle has probably been refurbished to the standard 80 overhaul process. So this is honestly a theme for a separate video, but it's basically kind of a standardized criteria on how to overhaul these rifles to guarantee some semblance of consistency. So in this case, you can see just how much work goes into the entire service life of the rifle. In this particular case, we have an SIG employee. In real life, SIG only assembled 10% of all Stgw 57s. The major contractor for the assembly of finished rifles is in fact Waffenfabrik Bern, interestingly enough.
Puis au contrôle.
Now what's interesting here is that this is actually not an Army Stgw 57, but a PE Stgw 57. And you can see here the scope base, or the scope mounting interface for private rifles. Since the video was made around 1986 or 87, at least this particular sequence, the contract for Army rifles that have the scope base for the infrared and the day sight has already long been finished, I think in 1970. So this right here is, I'm almost 95% sure that what is being shown here is basically a PE Stgw 57. And these basically are assembled with all mil-spec components, except for some specifically PE parts, to avoid mix-up between Army and private rifles. But interesting to see how it's being checked here. You can see basically the operator is checking the left side of the bolt for the bolt gap. The tolerance depends on where you are. I believe that from the factory at SIG it's between 0.5 to 1 millimeters. When it is inspected and delivered to the Army, the upper tolerance is stretched to 1.1, and when the rifles are refurbed, it's between 0.6 and 1.1, if I'm not mistaken. So depending on where you work, the bolt gap tolerance can vary basically from establishment to establishment and standard to standard.
Et enfin, au tir de réglage.
Prenons l'exemple du fusil d'assaut, cette arme personnelle du soldat suisse, pour illustrer le processus de développement d'armes nouvelles.
Now, all rifles, 100% of factory assembled rifles, have to undergo a certain number of test rounds. Now in this case you can see this is the standard test that is applied to all rifles. It's 6 semi-automatic shots, 18 short bursts, and 18 continuous bursts. So you can understand that with hundreds of rifles being assembled every day, the cost of ammunition really adds up. I can only imagine how it's like to be the person actually responsible for test firing. It must be a pretty boring and nerve-wracking job, to be honest with you. Now, what is being shown here is the extensive test firing. So roughly 5 to 10% of assembled rifles undergo this treatment. Basically, it's 18 rounds of continuous fully automatic fire with the weapon in the horizontal position, vertical pointing up, and vertical pointing down. So this is kind of an in-depth function test firing.
Was bedeutet Ihre Arbeit für Sie?
So what happens here is kind of a simultaneous zeroing, sighting in, and precision check. You can see that the rifles here are lined up, and this is kind of a machine rest. The purpose of this operation is to coincide or set the sights to have a 6 o'clock hold at 300 meters, or actually the 3 red position, which is equivalent to 360, 12 o'clock, so 300, 6 o'clock. Now you can see right here he has a little TV screen which shows the target that is at 100 meters, and the actual target is pasted on the wall behind him. So it's kind of a zeroing target. You can see there's a circle and a square, and on the bottom there's a cross. So the idea is that he would coincide the sights with the cross once he has the rifle installed on the firing machine, and then fire 6 shots in semi-automatic, and the shots have to fall within this 11 by 11 centimeter square to fulfill the precision and zeroing requirements.
Die Sturmgewehre hier beim Einschießen würden dabei vorwiegend Kunden unter den Entwicklungsländern finden.
So here you can see here he has placed what is called a Ziellineal. I actually have one in the reference collection that I could show you in a future video. Basically it's kind of a ruler with a little spike on the rear to interface with the diopter, and in the front there's kind of a leaf spring that clamps around the front sight. So the idea behind this optical tool is to give you kind of optical feedback on where the sights are pointing. So depending on where you're hitting, you would actually adjust this, and that's how you actually coincide the sights with the impact point. So relatively interesting here.
Denn vor allem diese kaufen fremde Handfeuerwaffen. Ob sich mit dem Export jedoch die Zeit bis zum nächsten Bundesauftrag überbrücken lässt, ist ungewiss. Es ist dies das Schicksal einer auf sporadische Bundesaufträge angewiesenen Industrie.
Ihre persönliche Waffe. Macht mir ab.
687, 614B.
687, 614B.
Oberleutnant Rekrut Wolken. Ihre persönliche Waffe.
Macht mir ab.
So that basically concludes the video. I hope you enjoyed it. Honestly, there's still so much to say about the individual processes in manufacturing. I only wish that one day we would be able to actually talk about the complete manufacturing process for the rifle. So again, I hope you enjoyed the video, and I'll see you in the next one. Have a nice day or evening wherever you are, and take care.